Hello everyone. So basically, I am the person behind this course. So let's see introduction about me. So basically, I am a security researcher and I am pursuing computer science, the integrated dual degree, BTech and MTech in an ATH. Okay. So basically, I have been acknowledged by a lot of organizations like Google, Ola, United Nations, Networks, ClickUp, and lot more organizations. Till now, I have conducted workshops and talks regarding bug bounty, and I have these 100 plus students till now online. Okay, and they are all doing good. So you can see my write-ups at Medium, and you can connect me via LinkedIn. So thank you so much. So this is my first course on Udemy. So hoping for the best. So thank you so much. So hello everyone. So I hope every one of you is doing well. So I am here with new course that is trace condition for bug bounty hunting on real world application. So pretty much exciting to know. Let's see the course content first. So well, every course start with its introduction first. So the very first part it is introduction, and in introduction we will see like what is the race condition and all, and what are its characteristics and what are its impacts. Okay, and secondly like what we can achieve with race conditions in bug bounty. So well, the new beginners who are enroll or who will enroll in the course will pretty much excited about like what we are going to do using race condition, like what are the vulnerabilities we will find and report to the companies and earn some good bucks. So you will find like a very good vulnerability using race condition. A very important vulnerability which is common to all will be a kind of bypass. You will be able to bypass lots of limits, or if we give name like you will able to do coupon code bypass, you can able to do like price manipulations, and you will be able to do rate limit bypass, and you will be able to do two-factor authentication bypass. Even I will show some of account takeover methodology, and I will show like collection of my POCs, like my proof of concepts, what I have find in real world applications, and I will also show some good collected proof of concept from the internet. So moving to the next section, we have types of race conditions. So in types of conditions, we have like limit overrun race condition, single endpoint race condition, multi endpoint race condition. Okay, time sensitive race condition. So we have different types of race condition, well, and we will study each and every of race condition with like some explanations and with hands-on labs as well. So for this course, I have referred to the ports figure content and labs as well. So I will explain each and every things to you. So I will make things easy to you. So don't worry about it. And after solving labs and how to work with tools and all, we will move to the real world part. So where I will explain you the race conditions in real world application, how to find it, how to exploit it, how to report it, how to increase impact. Sometimes we find race condition, but it doesn't have any impact. So we should keep these things in mind. Okay. So another one is like tools for working with race conditions. So a very important thing, like to find race condition, we should know some tools as well. Okay. Yeah, a very advanced hacker can write its own scripts as well, but we all are script kiddie, so we all need tools. Then we will come to identifying and exploiting race condition with help of labs. As I already explained, I will do hands-on and explain on ports figure labs. So we will understand different types of race condition, identification and exploitation. Then identifying and exploiting race condition on real application. So where I will show you the different uh, collection of proof of concept where I will able to do bypassing like business logic conditions, claiming coupon code multiple times. Okay, so whenever any beginner see race condition, so the very first thing comes in his mind is like, yeah, we can bypass coupon code, or sorry, we can use coupon code multiple time with race condition. And I will also show like how can you access some premium features which can be accessed using subscription only using race condition. So we will bypass that thing, and I will also show you And at very end, I have bonus section. I will explain you the account takeover methodology and tips to avoid firewall. So, so why I'm telling you like firewall kind of thing? It's because we are playing with multi-threading kind of thing. So it means we are playing with a lot and lot of requests at a single span of time. So this will trigger firewalls. So along with learning race condition, we should know how to tackle some kind of blockage and like that kind of thing. So we will definitely see all of these things, you know. So see you in the course. Thank you. Hello friends. So let's get started with our introductory section. So before directly going into identification, exploitation, and reporting, we should know what race condition is. So let's get started. So a race condition refers to a vulnerability where the outcome of an operation depends on the sequence or the timing of events. And exploiting this vulnerability can lead to unauthorized access, privilege escalation, or other security breaches. Race conditions in bug bounty programs are often sought after by security researchers and hunters because they can potentially lead to serious security implications. A race condition attack uses carefully timed requests to cause unintentional, oh sorry, intentional collisions, because collisions are intentional. We want to perform collision, so it is not unintentional. It will be intentional, and exploit this unintended behavior for malicious purpose. So basically, it's a game of requests, or it's a game of timing. So you manipulate the request in such a way that they perform a kind of collision. So in upcoming lectures we will see that collision will be performed in race window. Okay, so we will see that thing. So let me summarize this thing in easy way. So suppose here are some processes and here is shared resource. So let me write, so let me increase the font here. Share resource, and suppose these are process P1, process P2, process P3. Okay, you can also consider this as a request also. So in general we are talking about race condition because race condition also happens in like memory also. If you study race condition in operating system, so there we will study processes. Okay, so don't worry. So here you can consider this as request also. Suppose these are three requests and or processes. So if they want to like interact with the shared resource at the same time, okay, so if they are working in a synchronized manner, so that's not an issue. The application work intentionally or properly. But if requests or multiple requests or multi-threads or multiple processes try to access the shared resource at the same time, then a collision will occur. A collision will occur. Okay. So in general, this collision will responsible for unintentional behavior of application. So in this condition, maybe application stops working or crashes, but sometimes application processes these requests and unintentional behavior occurs. And that unintentional behavior can cause multiple vulnerabilities or can create multiple, you can say, types of vulnerabilities like privilege escalation and all. Okay, so it means we try to take benefit of this collision. So, okay, so basically in easy way that's the race condition is. And race condition is a vast topic. If you want to learn in more depth, so you can read like articles related to race condition, because it race condition are also happens in our memory level. Okay, but we are interested for the bug bounty purpose, so we will deal with only the request responses and the application. Okay, so hope you understand this. So most of you now be thinking like, here I have written like race condition attack uses carefully timed requests to cause unintentional collisions. So you all know the application is already developed by developers, okay, and all the events are working in a synchronized way, okay. Then how we will like change the timing of request or manipulate this timing? So we will see, we will do that with the help of tools that are provided by uh, web store or bots figure also, and there are other tools as well. So it is possible to create collision. So that's the thing. So it is very similar to the condition. Suppose there is a race, okay, and suppose there is a marathon, okay. So at the end point, okay, or if the guys who are running, if uh, at the end like two or three guys and at the same time, then how will you decide who is the first, who is second, and who is third? So a very similar thing will be happening here, okay. So like before getting into the server or into the shared resource, multiple threads enters at the same time. So that's the very simple example I can give. So let's move to the next slide. So characteristics of race conditions. So if you understand race condition that I have explained, then you will understand easily. The first one is unpredictable timing. Well, we don't know. The timing will be very unpredictable if we manipulate the timings of requests. We don't know whether the first three requests or first five requests will enters the shared resource at the same time, or first four, or like it is mostly unpredictable. So race condition occurs due to unpredictable timing and interleaving of operation in concurrent environment. Yeah, definitely. So for instance, when multiple actions occur simultaneously or in rapid succession, the expected outcome may not align with the intended behavior. Okay, so as intentionally, if application wants to give some output in a intentional environment, but if we are manipulating requests and multi-threading it or multi-requesting it at the same time, then the behavior will not be same. So that's the unpredictable timing. Second is shared resources. So race condition typically involve shared resources such as data, structure, files, or memory segment. Well, the data is coming from the database, so there will be definitely data structures, files, or memory segments there. So basically, you are like uh, interacting with the storage, so which are accessed and manipulated by multiple threads, processes, or users concurrently. So it is understood. So inconsistent state. So due to lack of proper synchronization or validation mechanisms. So synchronization here simply means the flow in which the application is working. Okay, like one after another, the second request will be sent to server, then third, then fourth. It means it is working in the synchronized manner already. But you are disturbing that synchronization, and definitely uh, collision will occur and all that unpredictable things. The state or of shared resources may become inconsistent, leading to unexpected behavior or security vulnerabilities. So that's the basic cause which is responsible for the inconsistent behavior and which will lead to security vulnerability. So we will see that thing also. Okay, so most of you may be confused how this thing will like this thing will affecting the server. We know this thing will affecting the memory, but how will how we will get the benefit, how we can what we can do from this. So we will see that thing also. So don't worry, just keep on hold, we will see all the things. So now let's see like what we can achieve with race condition. So exploitation scenarios for a race condition. Very first is privilege escalation. You all know the privilege escalation thing. There are two types of privilege escalation: horizontal and the vertical. In the horizontal, the roles or the privileges are almost same. You are just moving from one user to another. But in vertical, you are escalating your roles. Okay, suppose you are a normal user, and using privilege escalation, you are escalating your roles from normal user to admin level or super user. So that's the privilege escalation. You may have performed this in idors, like indirect object reference vulnerabilities, where you manipulate the user IDs and enter to other account, or you can see other user data. Okay, but we can perform not the very same kind of thing like manipulating user ID, but we will see that thing. We will perform a collision, then maybe we can able to see other user data. So Exploiting a race condition may allow attackers to escalate their privileges within the system. For example, an attacker could manipulate the timing of operation to gain access to sensitive resources or functionalities that are otherwise restricted. So let me give you a very simple example. Suppose uh, there is a update email address feature, okay, and what you have done, like you proxify the request and manipulated your email address with some victim address and try to multi-thread that request, like you are sending your account request and the uh, victim request in a like same time, very same time. So like you perform race condition. What happens if the email verification of the victim comes to you? So if it is possible, then we are able to perform privilege escalation. How? Like you change victim email as the admin email of that target, and the email verification of the admin will comes to you, and that's all the thing. I'm just giving you a normal example, like how, yes, in this way we can perform a privilege escalation using race condition. Data corruption or leakage. So race condition can lead to data corruption or leakage if multi-threads or processes attempt to modify or access the same data simultaneously. Attackers may exploit this behavior to manipulate sensitive data or extract confidential information. So like data corruption occurs when you perform multi-threading and application crashes, and during that crash it will return some sensitive information to in form of like errors. And one case that I have seen personally is there was a file upload feature and I performed race condition of that endpoint. So uh, intentionally it should return my file URL and other metadata of my account, but instead of that it was returning some sensitive data of other users because uh, there was data corruption. So still I don't know actually how it was happening at the back end because I was not having the backend code. But yeah, you can say luckily I am getting the other user data via race condition. So let's move to another. Authentication and authorization bypass. In web application or APIs, and race condition may result in authentication or authorization bypass vulnerabilities by manipulating the timing of authentication or authorization checks. Attacker could gain unauthorized access to protected resources or functionality. Okay, a very simple example. So suppose there is a rate limit of 5 requests or simply 10. Using race condition, what if you bypass that 10 request rate limit? Very simple. So there will be lot more example, but I am just explaining you in a simple manner. Okay, so I hope you understand what race condition is, what are its characteristics, okay, and what are the exploitation scenarios, like what will you achieve at the end. So now let's see one more example of race condition. So you will understand race condition more clearly through this. So before explaining this, let me explain you some other thing. Suppose you are doing bug bounty on a e-commerce website, and here is a like apply coupon code option, and here is like input kind of parameter, and you have two codes. Suppose you have two code. One is like ABC 50 for 50% off, okay. Another is XYZ 50 again for 50% off for the same target. So intentionally what happens? So we are like I am explaining intentional behavior. Like if you apply this code here, okay, so it will show a message like 50% off applied simply. And if you try to apply it again, it will show error like coupon code applied already. It means if you are not like manipulating any request or sending multiple requests, so what happens? You will send first request, suppose a post request for the coupon, and it will send to the server and it will apply the coupon to your account. If you send another request after this, so like first this and second request again, then what happen? Error will be returned in the response. But what if you send the same request in under race condition? If you apply a race, like you send multiple requests, now again keep one thing in mind, we are sending this in parallelly, in a parallel manner, not in synchronized way. It means they are like they will you can say they will approach the server at almost same time. So what happens, this coupon code will applied three times. Okay, so the first coupon will apply 50%, another will again apply 50%, and another again will apply 50%. So the coupon code will be applied thrice. So that's the race condition basically, and in you can also see the response as well. So we will see all these things in burp repeater. Using burp repeater we will see the responses and the requests. So that's the thing. Okay, so in the in this diagram, so that we are performing, there is a gift redeem request. Okay, and one more thing, uh, let me tell you. So in real time, or in, you can say, in actual practice, we say that we send this request parallelly in almost same time, but still there is a very minute difference in different in timing. Suppose in nanosecond or millisecond. Okay, suppose here the request having difference of 1 second, but here the difference will be very less, that it will be almost treated parallel. Okay, yeah, so let's come to this. So here we have sent 5 requests parallelly, and what we have seen, like the coupon code is applied 3 times, and then we are getting message of invalid code. Again, this is due to the like behavior of the request. So basically this is due to the fact that using tools we can achieve a race condition, not actual race. So we are just achieving the condition. Still, these requests have some minute difference in the, you can say, the latency. They will still have some latency. Yeah, that will be in some like nanosecond or microsecond, but still they have some latency. And in that latency also, we are achieving the race condition. So some terms will be there like race window, and all these condition it's performed under a race window. So we will achieve race window. So I will explain what race window is using some other explanation or some easy way. So here this can happen when multiple distinct threads interacting with the same data at same time. Yeah, again here I'm already showing you like that I have like send it 5 requests, and but only 3 requests works. Other two are not working because somehow they are out of collision, or they are out of a race window, so resulting in a collision that causes unintended behavior in the application. So that is the unintended behavior. Like coupon code should be applied only once, but in a race window or race condition, we are able to apply this code thrice. The period of time during which a collision is possible is known as race window. Simply the requests that are responsible for a collision. Here are 3 requests. Maybe they can be hundreds. 100 requests can also create a collision or a race condition. It depends in like how much requests we are sending in X span of time. It depends. Suppose in 1 second. So there is a tool. We will see the tool. The tool is able to send 10,000 requests in 1 second. 10,000. You can, if you imagine 10,000 requests, then it will be very huge. And the maximum uh, like the max record of the tool is 30,000 requests per second. So you can imagine if we'll send 10,000 requests in 1 second, then definitely it can cause a race window, or definitely can create a collision at the server. Okay, also some of you may be thinking like how application is applying code thrice, why is it not checking? Yeah, it is checking, but checking also takes some time. The check is performed like under some 0.5 second or 1 second, and in 1 second we are playing all the game. During the check time, if there is 10,000 requests under not a queue or not a queue, they are almost parallel. So you can understand, like, we are playing with the timing. So there are some technical terms which may come during lectures like network latency, jitter, and internal latency. And in general, these are like kind of a delays. Okay, if you send one request from your system to the target server, then there may be different kind of delay that a request face during traveling from your system to the server. Like the first one is network latency, and you can relate from the figure as well. Suppose this is an example of a request. Suppose it's approaches any server, okay, from your system. Then first latency that it faces is network latency. So network latency refers to the time it takes for data to travel from one point to another within a network, typically measured in millisecond. Okay, so it is easy to understand. Latency means delay basically. If latency is high, it means the delay is high. It means it is taking more time to reach to the server. Okay, suppose there is some changes in physical condition of our environment, then maybe there is a difference in latency as well. So latency depends upon different factor as well. Okay, if you read network latency in more depth, then you will able to see other factors too. So let's move to another one, that is jitter. Jitter refers to the variation in the time it takes for data packets to travel from the sender to the receiver in a network. Unlike latency, which measures the overall delay, jitter focuses on the inconsistency or variability of that delay. In other words, jitter is the fluctuation in the latency. So basically, jitter measures the fluctuation in the delay. Okay, yeah. So basically, the different condition I am saying already, that the network latency may depends on different factors, so that may fluctuate the latency. So that is jitter itself. The last one is internal latency. Typically refers to the latency experience within a system. So basically, it is a kind of delay in the system. So in which system we are talking about? So we are talking about the target system basically, rather than across a network. It encompasses the time delay incurred as data move through various components and process within the system itself. So internal latency may be occur in our system as well, but in general we are talking about the target system. Why? Because all the processes and all the, you can say, the calculation and all will be taking place in the target system. Suppose we send a request related to some suppose we are logging in any website, then there will be kind of internal latency because it will take some time in the, like, authentication and authorization processes and all, and assigning token to us, then it will take some time. So that time we can say it's the kind of internal latency, the time taken by the server to process our request basically. So you can see in the diagram as well. Okay, so after all that, a race window is, you can say, formed basically. So it's you can say the condition or the area where race condition can be possible. So if we send requests in such a way that it meets the or you can say it meets the race window basically, the requests, like first request is here, you can see. So race window is the area where the probability of collision is high. In simple words, race window, the probability of collisions are high. Okay, so that's the thing. So these are some technical terms we should know. So let's move to another. Now here is the types of race condition. Well, so race condition also has its types. The first one is limit overrun race condition, multi-endpoint race condition, single endpoint race condition, and partial construction race conditions. So these are all the types, and we will see in upcoming lecture. Yeah. So I'm giving an introduction related to tools as well. So which tools we are using here? So well, for race conditions, these all tools. Other than these, there can be other sources as well, but mostly these tools are used to nowadays, like turbo intruder, burp repeater, and these are some tools from the GitHub you can see. And race condition can also be achieved using curl command in the Debian based system in Linux. Suppose Ubuntu or Kali Linux, you have curl already installed in your system. So you can also achieve race condition using flags like parallel Z and X. Okay, so you can see in the documentation of curl how you can do. But yeah, in this course we are mostly using the above two, the turbo intruder and the burp repeater. And burp repeater is like, I think, easy to use, and again turbo intruder is also easy to use, so not an issue. So let me show you the GitHub tools. So here you can see we have RC phone tool. So we are not using it in this course, but I am just let let you know. So I am just letting you know, like, these tools are also available in GitHub. If you want to use some open source tool for the race condition, you can use. And here is another one which is racer. You can also use this tool. Okay, but we are mostly using turbo intruder and the repeater itself. And the Bob suite has already updated the repeater in the past 2023. So we'll see in the lab, while solving lab we'll see, so not an issue. So if you go to Web store, let me, so you can simply install turbo intruder from the Web store. Okay, you can simply just uh, click on install button and the tool will be installed automatically. So I have already installed, so that's why it is showing this reinstall option. So here you can read more about the turbo intruder. If you want to read more about turbo intruder, like more features and all, you can go to the documentation and can see about turbo intruder. So we'll see in the lab. So thank you. So hi there. So let's get started with first type of race condition, that is limit overrun race condition. So this type of race condition is usually found in the cases like where the application has imposed some kind of limit on their features. So you may have known some kind of features like coupon code feature, where we can apply coupon code only one time. Okay, if you try to apply the same coupon code again, you will encounter an error like the coupon is already applied or something else. Some other limits like rate limit kind of feature, like application has limited the request to 1000 only. Above 1000 you can't send request to the server or the target. And if you have encountered more kind of limits like rating features or the likes feature in the social network website, you can like only one time in a social media website. And suppose there is other feature like voting system, so you can vote only one time, but you can try to bypass that thing using race condition. Okay, so what limit overrun race condition is? So limit overrun race condition is a specific type of race condition where the violation occurs due to exceeding predefined limits or boundaries within the system. So that's the thing. So you are basically bypassing the limits. So this type of race condition typically involves the concurrent manipulation of resources or data structures where the limit is enforced. And if the multiple threads or processes operates on these resources simultaneously, they can collectively exceed the defined limit, leading to the unexpected behavior or insecure behavior. It means if the target has applied some limit like 1, 2, 3 or 1000, if you try to bypass or overcome that limit, and this will be limit overrun. So this type of race condition enables you to exceed some kind of limit imposed by the business logic of the application. So while reporting, you have to report like race condition, and further you have to write like bypassing these features. So that's a kind of business logic vulnerability. Okay, so here is an example. Like, let us consider an online store that lets you enter a promotional code during checkout to get a one-time discount on your order. To apply this discount, the application may perform the following high-level steps. So it's an example of coupon code or promotional code or any code which can be only applied once. Okay, so check that you haven't already used this code. So these are steps. Okay, the very first step, if the code is applied by someone else, then the code will not work. Secondly, apply the discount to the order total. And third will be update the record in the database to reflect the fact that you have now used this cookie. So if the code works, then you will definitely get a response that the code is applied successfully. Okay. So below is the diagram, like what should be your method or methodology to find these kind of conditions. Well, these limits are easy to spot on the target. Like if you have uh, done proper footprinting of the target, or you have seen all the features, then you may guess or even directly see where the limit is imposed. So the first step, you have to predict like where the limit have been imposed by the application. A very simple example, the promotion code thing. Second is the probe. Like if you find the feature, then you have to probe, like you have to check with different kind of methods and all. We will see using lab. Like you have to play with the request. Okay, then after proving step is the basically the reporting part. You prove it and make a proof of concept, then report to the target. So here is an extended example of the same. So without race condition, the code will work intentionally as expected, and if used once, then same code can't be used. So below is the diagram showing two requests and which are sent in a sequential way, not in a race condition. So at very first step, or the very first request, if you send the request with the code which is not used, then when you apply, the the state will be saved at the server, and the variable like code already used, which is a kind of boolean expression or boolean variable, is set to true, and it will be saved to the database. Now if you send the same request again, okay, so as you know, the state is saved the state is saved with this boolean variable which is set to true, then you will get an error, that is invalid code, because it is already applied. And now if you send the same request under a race condition and with the coupon which is unused, you haven't used the coupon code, and then under race condition both requests will be potentially be executed. Okay, not in every case. If they have applied a secure mechanism, then there may be not a chance that it will execute. Now below is the diagram showing the two requests, like the first one and the second one. Now they have sent to the server at the very same time, and both coupon will work, and same coupon is applied multiple times. Okay, here is the example of two requests. We can do it with 10 requests, 20 requests, and 100 requests, and so on. Okay, so let's understand this thing using a lab. Now let's go to the lab. So here is the lab, as you can see here. So limit over and race condition. So this lab purchasing flow contains a race condition that enables you to purchase items for an unintended price. To solve the lab, successfully purchase this product, lightweight leather jacket. So let's access the lab. I think, is it working? Okay, so let's wait for a minute. Yeah, so this is the lab. So now our target is to purchase this product, and we have just provided with this coupon code, that is promo 20%. So basically we need to decrease the amount at such level we can purchase it using this coupon code. So let's first log into the account. Yeah, so we are login and we have just $50 credit in our account. So I think you understand that we have to purchase such item in $50. So well, we know the limit is at the coupon code input. So we have to directly move to that endpoint. Yeah, so here is our item and we have to apply the coupon code now. So here lot of things comes in your mind that is this uh, coupon code validation is saved to the server with our session or not, like the state depends on session or not. So don't worry, firstly we check this thing and it will definitely work as it is a lab when we are logged into the account. In another case we will check the same thing again when we are not logged into the account, like that there will be two cases, the authenticated and unauthenticated case. So let us see the authenticated case. So apply coupon and proxify the request. Now one more thing, so don't uh, use any scanner while testing race condition, because if you run scanner, so at the background the scanners already sends request and definitely you will not achieve any kind of race condition. So do it without any scanner. So now proxify this request. So here is the request, as you can see here is the coupon code. Now send this to repeater. And one more thing, you require burp suite 2023.9 higher version, because below this version the repeater is not upgraded. As I already told you, we will use two tools, the repeater and the turbo intruder. So firstly I will show using the repeater and what they have updated repeater, what they have updated in this repeater. So we are not performing race condition now, like if you so so we are not forwarding the request, let keeps on hold. So let's send the request. So as you can see we got a response that the coupon is applied. Now if we try to again send the same request, so coupon already applied. So previous request was showing response that the coupon is applied, which is intentional, and the second one is showing coupon already applied. It means coupon can be applied only once. If we forward this request, definitely we get the same response that the coupon is already applied. Yeah, so coupon is applied just only one time, as you can see here. So but we want to apply coupon multiple times. So what we should do now? So yes, we will try to perform a race condition. So again apply coupon code again. So again important thing, you can't apply race condition on in the proxy tab. So don't forward this request, just keep this request on hold. Okay, because this is the limit case. If you send this request, limit will be achieved, as the coupon code can be used once. So we are not using or not forwarding this request, so we will play in the repeater. So now what you need to do, like send this request to repeater multiple times, like I have sent it this request some multiple times and the same request. So you can just press Ctrl plus R. So here is the request. Now what you need to do, add to group. So if you don't have group, create a tab group. So I can write limit overrun race, anything you want to write. You can select all the requests, any color you want or not. So let's see now what port figure organization has updated. Like they have provided now multiple option with this multiple requests. We can send this in sequence in single connection, we can send in sequence in separate connection, and we can send this number of requests in parallel in single packet. So definitely race condition can be achieved in parallel request. Yeah, but these two can be used for the probe section, like for the analysis section I have already uh, already explained you have to probe the things manually. So we have already do so we have already done that things like analyzing different requests at different time. So at sequentially it is working intentionally, but we want to achieve race condition. So send group in parallel. So I will also explain you what these two means, like what group of sequence in single connection means and what group in sequence in separate connection means. So let first solve the level and I will explain, so don't worry. So let's send. So in group what happens, these all requests are compiled together and you can play with multiple requests at same time. So let us send. Yeah, so this is the first request where coupon is applied. Let's see second. So coupon again applied and you can see the coupon. Yeah, the first for request the coupon is applied, but at sixth coupon already applied message is shown, it means it is not working. And yeah, and 10th works, 11 didn't work. So yeah, so this is again comes in probing section, like we are playing with multiple requests and analyzing the responses. So as you can see I have tried like 15 of requests, and if we see or if we analyze, then some works and some requests didn't work. Yeah, but we are successfully able to bypass the limit. So now you can forward the request and definitely it didn't work or it will not work. Yeah, as you can see promo code is applied multiple times here and we get a total of here, but still we can't able to purchase the product. So we need to perform the same thing. Okay, so we have already multiple requests related to this. So I have removed the coupon code and now I will again add some more requests here, like adding some 30-40 requests. Now again let's send this. So let's try to check from the first request. Yeah, it is applied and some of them are applied and some are not working. So better to be check at this point. Yeah, again very less request works, but still we are not able to achieve the goal. Like we have to decrease the credit to so $50. So again send. So let's try to see how much of we are getting here now. It's still very less. So let's try again. Oh, I think I have done a little mistake. We have to remove the token. Sorry. Now let's send again. Now check. Yeah, we are close to 50, but still not 50. So better to be adding some more requests. And yeah, remove the token first. Now let's send. So there are 40 requests. I don't know how much of them work, and yeah, now it is close to 15 and we can place the order at it is below the credit. So we have, so let's place it and we have solved the lab. Okay, so this is how we can achieve a race condition. So let me explain the multiple things here. So now I have made a tab group where I have compiled all the requests. Here you can see in the red color, and I can play with all these requests multiply at one time. So basically I am able to play with these multiple requests at one time, and there are some other option as well. So for race condition, this option is used send request in parallel, as we have already seen in the introductory part and explanations that the parallel requests are important. Yeah, but in very rare cases or some cases, the other two option can also be used in race condition, but at very rare case. because it depends upon the timing. So you have to like achieve such a timing, like you have to make a collision. Now what other two means here? Send group in sequence, single connection. So basically we are sending all the requests but in sequence, not parallelly. In single connection, it means a single packet. And other is separate connection. We are sending requests in sequence but in separate connection. So definitely you go to a difference that if we send in separate connections, every request uses different network. Okay. So but in single packet, all the requests are sent using one network. So definitely uh, the different requests in like the request in different connection will create you can say more overhead to the server, but in single connection the overhead will be less. So you can like read more differences related to this. Yeah, but in parallel, in single packet we are sending requests in parallel, so that we want to perform a collision to achieve race condition in the race window. Okay, in the diagram during introduction to this point we have seen some diagrams where there is race window. So to enter that race window we need to send request in parallel. Okay, so now let's see the same lab using turbo intruder, other tool. So let's again run the lab. So now let's try to perform the same thing using turbo intruder tool. So the turbo intruder tool is very powerful tool. It can send up to maximum of 30,000 requests in 1 second, but at its very max. But in normal usage it can send up to like 10,000 requests to 15 or 18,000 requests in 1 second. Yeah, but usually I will I will like prefer the repeater thing. So I will more prefer the repeater because uh, turbo intruder in case of real targets or real applications can trigger firewalls. So that's why. So it is used to like try to use very less requests to check for race conditions. So basically the turbo intruder is used for the mass scale race condition. So again we have already used some credit and we have 34 credits. So now let's try to exploit some other item. Let's try to exploit this one. Adding cart. Now if we apply, now go to cart. If we apply promo code, so again we have the total of $68, which is again more than our credit. So again we have to apply more of, then we have to apply race condition. Now what you have to do, like apply code and capture the request. Now I will tell some more thing, like some mistake you can do here. Now send again to repeater. Okay, so we are done with this request. Now we will focus on this new request. Now if we forward this request, the coupon is applied. Okay, so we don't want to send again that request which is already sent it to the server. So remove the coupon code. Now in repeater you have to open your extension and here turbo intruder and then send to turbo intruder. Okay, and here you need to choose raise single packet attack. Okay, raise single packet attack. There are some other type of code as well for they are for some different kind of race conditions, so we will focusing on this one firstly. So yes, we have selected the request and the code. Now you can increase the range as well, you can customize the code as well, but we are going with default one. Yeah, so it worked. So we just uh, use 20 requests here. Okay, you can also use 10,000 and hundreds. So let's see if open code applied or not. Yeah, you can see here coupon code applied in lot of the request. So both tools are great. Repeater is more kind of manual and turbo intruder is more automated, and it is much powerful tool. Even it can crashes the application. Sometimes it will crash the application and you may get error 503 not found and all, sorry, internal error and all. So it depends on you which tool you want to use. And in case of firewalls, if you have firewalls like Akamai, Cloudflare and CloudFront, then they will block the multiple requests and all. If you send hundreds and thousands of requests using this tool to achieve any or checking for race condition, then you will be blocked definitely. So try to use or try to check with 10 requests, some 15 requests. So that will be good for starting. We have successfully applied coupon code. So let's see. Yeah, so we have again reduced to $3. So again we can place the order. So we have already sold the lab. So that's why it is not showing the sold again. So now one thing that should come in your mind, like we have checked race condition when we are authenticated. It means when we are logged into the account. But if I try to apply coupon code when we are not logged into the account or simply unauthenticated. So let's log out from our account firstly. Now let's try to purchase this item. I am showing you some of the things which may comes in your mind. So here, if you note one thing, that when we are in our account, we know this credit, but here we don't have any kind of credit here. But yeah, let's see if we can apply coupon code multiple times here. So now again, go to the proxy tab, capture the request, and don't forward the request. Just send this request to repeater and keep this request on hold because you don't want to use coupon. So proxy is still on, but here what we'll do, we will check with like 6-7 requests. So here is the request. Yeah, again make a new tab group. So unauthenticated race. I can say try. I don't know what will be the response, but still you may question or you may ask in Q&A. So what should happen here? Like according to me, what should happen here? Like may or maybe not coupon apply because coupon application is tied to our user ID or session in intentional manner. But let's see what happen here. Yeah, you have to select send group in parallel. Okay, so keep this thing in mind. So coupon is applied. Yeah, coupon is applied. Coupon is applied. Yeah. So request is working as good. And if I refresh, it is loading because I have proxified the very first request. So you have to do one thing like, yeah, definitely. Because after sending 6 requests in parallel, I sent this request sequentially after like completing the race. So that's why it is showing coupon already applied. So it is understood. So as you can see, coupon is applied multiple times here again. So it means sometime the endpoint is independent of your you can say session ID or user ID, and applying coupon code multiple times using race condition in this case, in this specific case, is not attached to our session. Okay, so in unauthenticated user can also perform a race condition. So it will increase the severity little more. Yeah, but placing order needs your account to be authenticated. Now let's see what happen if I place order, then it will show login to continue. So definitely it's an intentional behavior. So I hope you understood how limit bypass or limit over a race condition is and how it works and what are the tools and how to work with tools. So in upcoming race condition example, so you will not face any kind of difficulty because I have explained the tools and how we have to work with this. Okay, so if you want I can explain in a very normal way again in the, or let me explain you, let me summarize you. So in any target, if you found this kind of feature, like in like coupon code, promotional code feature, or another features mm, like voting feature where you can vote only one time, and the like feature, or rating feature in social media website. Now what you want to do, hmm, capture that request. Now during capture, keep that request on hold, don't forward the request, and send that request to the repeater, and create multiple requests and create one tab. You can name anything to the tab, and then then select send request in parallel, the send request in parallel option in single packet or single connection option, and try to check the race condition using that simply. Or you want to analyze more, then you can use other two option as well, but they are using sequential request. It means the requests are like one after another, only the third option having request in parallel. Okay, so which will definitely a better option for performing a collision under a race window. So that's the thing for a limit over and race condition. So I hope you understand. If you have any question till now, you can ask, okay, in the Q&A section. So we have explained and performed the example using the lab. Now, so there are many variation of these kind of attacks, like redeeming a gift card multiple times, multiple votings and likes, rating a product multiple times, withdrawing or transferring cash above your account balance. So it depends, and because in banking website there is a lot of security regarding requests, so definitely I will prefer working with repeater tab in that case. Reusing a single captcha solution. So sometimes using captcha multiple times is blocked, but using race condition we can use captcha again and again. So bypassing an anti brute force late limit. So sometimes limits are you can say limited to like 4 or 5 for brute forcing, but using race condition, or simply like turbo intruder, we can analyze like are we able to bypass that limit or not. So this is for limit over on race condition. So we will see, or let's meet in another type of race condition. Thank you. So now let's see one more lab which is related to like or falls under the category of limit overrun race condition, that is bypassing rate limits via race condition. So this lab login mechanism uses rate limiting to defend against brute force attacks. Okay, so what you need to do, like you have to brute force the password for the Carlos and log into the admin panel. Let's see the lab. Okay, so they have defined some predefined password list as well, so we will see that thing also. So in this lab we are going to use turbo intruder, because if we use repeater group tab, then you have to separately update each request body with the different password, so that will be time consuming thing. And if you want to do on large scale or a real world application, if they have a rate limit or brute force security, then if you want to brute force with thousands of password, then it will be worthy to use turbo intruder. So let's see. So we have a limit of 15 minutes to solve the lab. So we need to guess the password for Carlos. If we, okay, so let us just proxify the request, because otherwise we have to again and again put the credentials. Now just sending it to repeater. let us render. Okay, so I think after putting two or three wrong password, we have a like rate limit mechanisms, or they have applied security here that we have to apply, or we can use the login page after a minute basically. So that's the prediction area. So where to predict, we know, we can see here. So in limit overrun, we firstly have to predict, then we have to probe, then we have to prove. Now we have already predicted, now we are probing. So if I refresh, and yeah, now we have some kind of 10 second to again try for attempts. Okay, so what we are going to do, like after it will come to the original state, like we can again apply credentials. We will try to use turbo intruder with this word list. So, and one more thing, so there may be a race window between when you submit the login attempt and when the website increments the counter for the number of failed login attempts associated with particular username. That means at the backend there may be a counter which is incremented after failed login attempt, and it applies a timer. So there may be a race condition here. Okay, so we will check this, and also they have given us a code, sample code we can use. Okay, so make it fast and simple. So I am just following the lab solution. Now what you need to do, just send this request to turbo intruder. Okay, so here is one thing, uh, in very first lab of limit overrun, I just simply right click and send the request to turbo intruder. But in case of a like parameter, like if like here we are changing parameter with time, sorry, with request, so you have to select the parameter. Okay, and then send, and you can see here the parameter is already marked. Simply now we just paste the copied code, and one more thing, you have to copy the word list and it will be saved to your clipboard. To check your clipboard, you can just simply press Windows plus V, as I can show you here. So it will be saved to your clipboard. So shortcut is Windows plus V. Okay. So even if you read the code, so it is uh, like fetching the word list, and the word list is fetched from the clipboard, as you can see here, and it is stored in the password variable. And here loop is applied, and password is used from the clipboard. Okay, so basically what it will do, it will you can say perform a race condition with different password at the very less time. So now what you need to do, just do the attack. Let's wait for some seconds, and here you can render simply. So basically we are as intentionally we are able to just check for two or three wrong or invalid password. It was giving error, but due to race condition we are able to perform, or we are able to perform more than two checks. So now manually you need to check for each request, like which password is correct. So if we analyze the responses here with different requests, you can start from below or the above. So as you can see here, for some requests we are again getting error, like now they have increased the time to 120 seconds. Okay, so you may have to perform multiple attempts. Okay, so what you need to do, like wait for some more time. Okay, so we have some time foundation here. So let's wait for some time. So let's try again now because we don't have the timing foundation now. Just perform the attack again. Now let's see the results. So after again analyzing the request and responses, so if you will see, if we get a status of 200, then we are getting the response as invalid username or password. But some of the 400 one, I don't know, like, but we are getting only one as 302 for the dragon. It means it is the password because we are redirecting to the dashboard. So let's try. Yeah, so it is correct one. So I have to again restart the lab because the time has run out, and I again perform this, and you can see here. So if you get a 302, then it is a success. So there is how you can bypass rate limit. So if we analyze, then actually what we have bypassed. So we have bypassed the usage of two invalid passwords. Or you can say three. They have limit. You can just use two or three invalid password, but using race condition, using turbo intruder here specifically, we are able to use multiple. Like if there are 30 password, we are able to use at least 20 to 25 of them because not all are uh, not all reach the race condition. Some of may again get an error, but still we able to do it. So again here the race condition is between when you submit the login attempt and when the website increments the counter for the number of failed login attempts. So there may be a kind of, or there may be a race condition between these two things. Okay, so again it is a kind of limit bypass, so it comes under limit overrun category. Okay, thank you, hope you understand it. So we have seen limit overrun race condition, so now let's see multi endpoint race condition. Okay, so basically the name suggests itself that it involves multiple endpoints. So a hidden multi-step sequence race condition is a type of race condition that occurs when multiple steps or operation needs to be performed atomically. It means if there are multiple endpoints or more than two or two, then they should work atomically, means independently. But in case of multi endpoint, they are somehow linked to each other because they are, you can say, uh, interacting with the same data. Okay. So, but the sequence of these steps is not adequately controlled or synchronized. Yeah, definitely, if they are not working in an atomic way, so it means they are not synchronized. In other words, the race condition arises from the lack of coordination between different threads or processes that execute a series of steps, where the outcome depends on the interleaving of these steps. If you can identify one or more HTTP requests that cause an interaction with the same data, you can potentially abuse these substrates to expose time-sensitive variation of the kinds of logic flows that are common in multi-step workflows. So this enable race condition exploits that go far beyond limit overrun. So see one thing, multi-endpoint is a bit tricky to understand. Okay, like in limit overrun, we are focusing or dealing with the single endpoint, but here we have to deal with multiple endpoints at the same time. Okay, so you may be like thinking how we can perform in multiple endpoints. So we will see and you will understand better. Okay, a variation of this vulnerability can occur when payment validation and order confirmation are performed during the processing of a single request. The state machine for the order status might look something like this. So if you try to understand the blow diagram, you may be confusing, yeah, you may be confused, a little confused, like what is happening here? Like here a basket is pending and we make a payment and payment is validated and basket is confirmed. So Let me explain you the scenario. So actually, what is happening here? So let me increase the font size. So we are adding and confirming at same time. It means you are adding the order and you are confirming the order at the same time. But how? So let me explain you with an example. Suppose you have $100 in your account, suppose, and in your cart you have like some item, say item one, which costs around $50. Okay, and here is a button like for order. Just considering a case scenario to understand multi endpoints, and this endpoints is name as checkout. Okay, so this endpoint is basically checkout. If you go to checkout endpoint, you can see your item, it worth, and you can order from here. Okay, so basically after clicking, this endpoint will be executed or it will be run. Now there is a cart endpoint, okay, where your items are shown basically. So you can see here the item is already here $50, but if I order, so I can successfully it will be a successful you can say, so this will successfully run basically as you have $50 which is less than your credit, so it will definitely work. But what if there is a $1,200 item, say item 2, okay, what happens, you send this request and this checkout request at the same time. So definitely if they are not working in an atomic way, if they are not synchronized, then this request, or you can say the request for adding this item and the checkout will work at the same time, and at the end I will able to purchase this item. So that's the thing we are doing here. Basically we are dealing with different endpoints, and somehow we are connecting the different endpoints so that we can do some, you can say, a vulnerable thing definitely. Okay, so let me explain again. There is a checkout endpoint, there is a cart endpoint, and in checkout endpoints you just order your you can say assets or value items, and there is a cart endpoint where you can see your cart, basically the items you have added to the cart. And in an atomic application, or sorry, if the endpoint is working in an atomic way, then you are able to purchase this $50 item. But what if I try to buy this item, still I am having $100 credit? So that's the thing. So we are doing this thing in this kind of race condition. So we are adding and confirming at the same time, and during confirmation we add a more valued thing to the cart, and when we check out, as a result, the more value item is able to purchase. Okay, so we are able to purchase the more value item by exploiting this multi endpoint race condition. So let's move to the slide. So that's the thing here I'm showing. So if a basket is pending, it means the cart, like in cart you have a low value item and you make a payment, then some time will be taken during payment validation. But during this time, if you add some other item in the cart, there is a potential chance that that item will also be confirmed by the server. So that's the thing, and this thing we will do in lab also. Okay, it is little tricky to understand, but if you like understand the thing I explained you just now, so you will not face any kind of difficulty now understanding this. Yeah, so there are some problems related to multi-endpoint race condition. Definitely the problems can arise in timing of requests. So when testing for multi-endpoint race conditions, you may encounter issues trying to line up the race windows for each request, even if you send them at exactly the same time using the single packet technique. So actually what they are saying is like I have given example of checkout. So checkout may be taking long time, maybe less time. So it depends. And if you are adding some other item and try to perform a race, then it might not line up with the race window. Okay, so that's the thing. That's sometimes we face problems. So what is the solution for this? So firstly, analyze the timing of request and try to perform race multiple times. So that is the basic solution for this. Firstly, like probing the thing and then proving simply, because we have already predicted that there may be race. So we have to probe the thing. We have to reach to the proof. And problems like delays introduced by network architecture. For example, there may be a delay whenever the front end server establishes a new connection to the back end. The protocol used can also have a major impact. Yeah, sometimes it depends on protocol as well. Sometimes payments are going through HTTP, HTTPS, sometimes through sockets. So sometimes timing will be different for different protocols simply. Delays introduced by endpoint specific processing. Yeah, I just told you, like sometimes checkout may take more time or less time. Okay, adding cart will having a like definitely same time, but checkout may have some kind of different time at different levels. Maybe if there is a congestion or more traffic on the website, checkout may be taking long time. So it depends. Different endpoints inherently vary in their processing times, sometimes significantly so. So depending on what operation they trigger. So yeah, it depends upon backend architecture as well. Okay, how it working. So it depends. Yeah. So let's see the lab and do some hands-on. So now let's see the lab for multi-endpoint race condition. Yeah. So this the lab purchasing flow contains a race condition that enables you to purchase items for an unintended price. To solve the lab successfully, purchase this leather jacket, and again you need a higher version of Burp Suite. I again told you, because lower version are not having that upgradation in the beta tab. So let's see the lab. Yeah, here they have told like when experimenting, we recommend purchasing a gift card as you later redeem this to avoid running out of storage. So we will see what they are saying actually. So let us refresh. Yeah, here we are with the lab. So we have to purchase this item, and here they are also providing gift cards worth of $10. So firstly we have to go to the account. I think we are facing some issues. Yeah. So we are in the account and we are having store credit, that is $100, and other options we are having gift cards, like we can redeem a gift card and just it. So let's go to the website homepage, and here you can see like the store credit is very less and the item price is very high. So using raise condition, we have to purchase this item. So now let's first see some request and responses, because I already told you what we have to do. Like we have to add and purchase at the same time. So it means adding means add to cart option. So here is this option like add to cart option. So we will also keep this in our verb repeater. So I am sending this to repeater and naming it as add to cart. Okay, just name is it, and let's see. Okay, and now placing the order and also capturing this. That's basically the checkout endpoint. So basically there are two checkpoints, the cart and the checkout point. So we get the two endpoints, it means it is related to multi endpoint. So sending this to repeater as well, and you can also see the response as well, but we are not interested this time. Yeah, so we have gift card and we can also redeem using the code as well. So what I'm trying to tell you, like the timing basically, because in multi-endpoint there is sometimes issue of timing. Okay, I'm just telling you, like sometimes time will be more and less, so it depends. If we follow redirection, okay, so let me again send. Yeah, the adding card will not take much time, but maybe checkout will take more time. Yeah, as you can see, it is taking 208 millisecond, but it is taking 520 millisecond. Okay, almost double. So, but using parallel request, we have to align them in such a way that a race window is basically a collision is performed. Just we have to perform a collision. Okay, so firstly, let's move to the cart. I have actually used multiple times, so maybe sorry, not checkout endpoint, the cart. And if we go to the home page, so as already I have purchased 3 gift cards, so definitely I'm having 3 redemption code. So let's redeem it. So this lab is not related to the coupon code. Okay, so that's why don't try to do it. Yeah, so now we have $100 credit for testing. Now let's perform the attack now. Yeah, we need to like purchase this item. Okay, but for this attack to work, we should have one item less than $100 credit. And the very first thing that comes in mind that the gift card. So add a gift card to your cart. And now what you need to do, let me name this as checkout, checkout endpoint. Okay, and we can change here product ID as well. So actually product ID one belongs to the leather jackets. Again, I can show you also. Okay, so if I refresh, you can see the leather jacket is added. Now here is the point. Now what I will do, I will place the order and add the leather jacket at the same time. So we need to perform this multiple times if it fails, because the timing may be different at different time, because but there may be case that collision can happen. So we are interested for the collisions, so it might take multiple attempts. Okay, yeah, you need to have the gift card in your card because there should be some item that is valid to be purchased. Okay, so keep this thing in mind. So we have the request for the leather jacket, as you can see, or simply I can say leather jacket add or checkout. Simply it is, that is okay. So I can name it as, yeah, I am creating group now. So just right click, add to tab, create tab. And one thing you should not do, like not add your not add to other groups, because if you add to other groups you will be merged with their request, so we are not interested in that. So multi endpoint race. So now what you have to do, just send request in parallel. So they both requests are sent in parallel, and before sending, just take care that the jacket should not be added now, because if jacket is already added, then you will get a error or because it will be failure, because you don't have that much credit. So request with both the product is sent basically at the checkout point, and it will check the credit and the total amount. So that's why, because there is a flow, you are adding uh, a more valued item and sending request of order confirmation with low value item that you can purchase. But if a clash happen between two, then the more value item is purchased because of collision. So there is a race between. Actually, you have to check. Let me refresh. Your cart is empty. Is it worked or not? I have to check. Yeah, I have purchased that gift card. So if I able to purchase jacket, then the lab will automatically solve. But I cannot see here like which items are purchased, so not an issue. Yeah, it means it didn't work this time. Let's see if I can see here. Okay. Yeah, now what you need to do, you have to add to gift card again. So I can do it simply. I can just go here and as a different request because I want to add gift card. I can just add two here and send the request. Because the first test didn't work, it means I have to apply it multiple times, and any one of the case or random case will work here. So if you go to, let me refresh. Yeah, as you can see, it is updated with one. So we have gift card. Now try to perform again. This one. Send in parallel. Now let's see if we are able to purchase now. Yeah, again, we are not able to purchase. Add a gift card and send request in parallel. The thing we can do. Now let's see. Again, only we are able to purchase a gift card. Again, let's. So definitely it would take some multiple attempts. So what if I do like uh, add some more requests related to the jacket one? Like I have added some multiple requests. Like if there are more requests which are adding jacket, then probability of getting jacket during checkout under a race condition will be high. So let's see. I am just trying. So let's see. Yeah, we have jackets, but I think we are not able to purchase. Yeah, I think the mistake I have done is add gift card, and we have gift card in our cart. Yeah, now go to this tab and send request in parallel. Now let's see if we are able. Yeah, so after some more attempts we are able to do, and the one little trick that I have applied, and again if you try to solve using the solution they have provided, you will again like fails lot of time. You will fail lot and lot of time. So probability of like adding the leather jacket during checkout will be high if the number of requests will be high. So definitely at this point I have added some more requests because with single request we are getting failures. Okay, so to avoid failure, uh, just increase the probability of high value product in this case. Okay, so hope you understand this thing. Okay, so again you can look here what we have done. We are adding and confirming at the same time. So keep this thing in mind because sometimes uh, rather than vulnerability explanation, words are more help helper of, like you can say, explanation. So from cart we add item, from checkout we order, and we are able to order low value item then our credit. But if we want to order a high value item with a low value item, what we have to do? We have to like send both requests in parallel, and if a race condition is achieved, then the higher value is also ordered. So that's the thing. And for solving this lab, and even in real life also, don't just work with one request, use multiple requests. Okay, so I hope you understand. Thank you. Another type of race condition is single endpoint race condition. So basically, if one thing comes in your mind like uh, limit overrun was also a single endpoint. Yes, it was also a kind of single endpoint, but it was specifically related to the limit, like some kind of business logic limit. Okay, but here we don't have any kind of limit, but we just play around with some kind of request at the single endpoint by changing some values in the body, like some kind of parameter like uh, email parameter or other kind of parameters. So a single endpoint race condition is a type of race condition that occurs within a single component or endpoint of a system rather than across multiple endpoints, as seen in multi-endpoint race condition. In this scenario, the race condition arises due to concurrent access to shared resources or variable within the same component or endpoint. Sending parallel requests with different values to a single endpoint can sometimes trigger powerful race condition. So let me give you a simple example to understand this. Suppose you have a password reset token endpoint or a forgot password token, and you capture the request, and you can see when you capture request, you can see your email and your email value. What happens if you send this same request multiple times and changing the email value to other users email value like victim email value, and after sending it, what happens if you get a victim forgot password token, sorry, reset token, then what will happen? You are able to take over victim account, or you are able to perform privilege escalation. So it's a kind of entering into account takeover category. So that's a single endpoint race condition. You may find other types of cases too, but we will see one case here like related to token kind of thing. We are able to get victim token. So let's see or understand with an example. So consider a password reset mechanism that stores the user ID and reset token in the user session. So the session containing user ID and reset token. In this scenario, sending two parallel password reset requests from the same session but with two different username could potentially cause the following collision. So if you see in below diagram, so in the same session, but we are using two different user ID, and we are trying to reset password. Okay, so like the functionality you can see in your profile or the dashboard. So that's the thing. So here you can see the two requests are sent in parallel, and what happens, the second request collided with the first, and a race condition is generated in the race window. So here what happens, uh, the token which was intended to be sent to the first user is not sent to first user, it sent it to the victim, and the victim token is sent to the hacker. So that's a simple explanation of this. Okay, so there can be more vast explanation using code examples and functions and all, but I try to be simple. Okay, otherwise you will be confused. Okay, so let's see the lab here, and you will understand from the lab easily. So in the lab, the target is very simple. The lab is single endpoint race condition, and the target is like we have to take over this email simply. Okay, so there is condition like someone with the address has pending invite to be an administrator for the site, but they have not yet created an account. Therefore, any user who successfully claims this address will automatically inherit admin privileges. So it means if we are able to take over that email, we are just getting admin privileges. So let's directly move to the lab. Again, the first step is to predict the area like where we can do some kind of race conditions. We have already seen limit overrun, multi endpoint, and the rate limit bypass also. So let's see this. Again, we need to enter to our account. Okay, so we are provided with a email server as well, or you can say email client, sorry. So anything or anything related to our email is associated with our email, it can be seen here. So let me try to update the email. So I'm entering a random email first. Okay, so basically the token is sent to that email which I have entered. Okay, it means here I will get almost nothing. Yeah, suppose I am using a temporary email website, and if I enter this email here, then I think if I refresh, I should get an email. Maybe it's a lab, so that's why it is not working globally, or you can say it is not actually sending email. Let me try to enter again. Okay, so I haven't checked before like it is working with working email or not, so I am just trying. So it is not working with the temporary email. So yeah, but what if I use their email client? Now here I should get, yeah, so I get a link to confirm email. Okay, like link for the link to a token to update my email. Just so I'm not confirming. Okay, so what we have to do here, like, is there any way like we can get Carlos email token to our email client? So we have to find a way. Like if I refresh, yeah, so we are just getting things related to our email only. So what you need to do, just capture the request. I am sending it to repeater email update, and when I send, then you can see here we are getting 302 response. And now what you need to do, so we have already predicted the area where there is a potential of race condition. Now we have to probe, like we have to find some clues related to this. So for this you can use the email client, and I'm entering test one here. Okay, so we already have the request, but not an issue. Let send this request to the repeater. Okay, so I have sent one request. It means email client will be showing another response as well. Yeah, so that's why. So now what we will see, so let me show you what you need to do, like make some copy of request. So from 63, like I'm writing just test one. Yeah, so now make a group. You can just write single endpoint race detect. So we first have to detect whether there is actual race condition or not. Then we will try to hijack the Carlos email. Yeah. Now what you need to do, just update emails with different values. Now they become different emails which are linked to the same email client. So I have just taken some 7-8 requests, and I think it will work. Now send request in parallel. Yeah. In response, you can't or predict anything, but here we can see. Now here we have to detect using email, you can say the receiver and the response. Like here if I see, the receiver should be test 4, but in body you can say, you can see here the email is actually changing to this, like it is intended to be sent to test 4, but we are able to confirm the email of test 8. Again if we see some other, test 6, test 8, test 2, test 8, it means the token which should be sent intentionally to that email is actually sending to different emails because of race condition. So now here we have proved, or we have like find the clues, like we can do race condition and hijack the victim email. Now what you need to do, just take this email, and now I am changing some requests here, like we are just we just play with two requests. So let me remove this from the group and change this to winner. This was test 8 previously, I am changing it to winner. Okay, and again I am making another request. So winner, or simply you can say hacker, or here is victim, and victim will be Carlos. Victim will be Carlos here. Now create tab. I am writing it proof ACT, means account takeover. So it's also an example of account takeover, and you can perform it in real life as well. I have personally find these kind of issues in some private programs, and they like give you a good bounty for this because it's an account takeover. So you may need to check it multiple times. Yeah, now we are getting winner email, but still it was sent to winner. It means it was an intentional behavior. Okay, so again I told you, if you want to increase the probability of an hacker, then you can increase the number of requests as well. But let's see, or let's try again. Now as you can see, it was intended to send to a winner, but you can see here it the body is showing the Carlos token. Basically I am able to confirm the Carlos token now. Yeah, email has been successfully updated. Now let's move to account. Yeah, now we are in Carlos account, and just a simple task to delete, so it is sold. Okay, so this was the lab. Okay, and actually this can be performed in real application as well, as simply as that. Just firstly find clues, like firstly I have tried with different emails like test1, test2, test3, and even they have provided solution as well, like firstly benchmark the behavior, like try to check the behavior, how it is behaving with different emails. And in lot of cases some target don't have race conditions, so they get like, if you send email to test1, then you don't get test2 response. So I think I should stop here, and you should practice here and try to understand. Okay, so thank you so much. So now let's see time sensitive lab. Okay, so the lab contains a password reset mechanism, although it doesn't contain a race condition. So but you can exploit the mechanism broker cryptography by sending carefully timed requests. So what they want to say, like sometime if we try to align request timing, then it can perform a kind of race condition for us. Okay, so we will understand with an example. And here we will see the session locking mechanism as well, like how some requests are tied to their sessions. So if we go to my account, then we have a forgot password feature, and we also have an email client. Okay, we can log into our account using this credential as well. So let's capture the request. Yeah, now let's send to repeater. So we can see time from here, okay, like 482 millisecond and all. If you are able to see, now what we have to see or what we have to analyze, let's just make a group test. And if I send these two requests in parallel, let's see the timing. Now the first is taking 564 milliseconds and the second one is 868 milliseconds. It means the two requests are not aligned. To perform a race condition, the timing is very important. So timing should be aligned. When the timing will be aligned, a collision will occur and so on. So the way they have told us to like bypass this kind of session locking mechanism. So what you need to do, like if you see both requests have same session, so you can change session of any one request. I am just removing this cookie and I am just sending current tab request, not the second one also. And it is giving some error, like it's not a valid CSRF token. I think, let's see if we are getting same error here. No, we are okay here, but we are getting same error. So I think we have to remove the token as well. Okay, sorry. So the way they have actually told us is like capture the forgot password request. Actually, we have to update this session ID and this token with some other values, because if you are sending same the two requests with the same token, then we are getting some time issues. So what we need to do, just capture this request, this request without username. We don't want username, or like let me tell you what we want actually. So we just want to capture this endpoint, just forgot password endpoint, and they have just told that remove this token because I think, is it the same value? Yeah, it is the same value, so we want different one. So there is a way, like remove from the cookie, and in response they are giving new ID. So in repeater we can update any one of that request. Yeah, we have updated, and again we want a CSRF token. Let's see if there is CSRF. Yeah, you can just filter out. Now you can forward it, and now I have successfully updated the request one session and the CSRF values. Now let's send in parallel. Now let's analyze the timing. Now now this 75 request is taking 564 millisecond, and yeah, both are taking exactly same timing. It means probability of happening a clash can happen here. Now let's go to the email client here first. So actually, how can we actually analyze that a race condition is happening here? If I send two requests and both the emails containing the same token, then there may be a probability of clash. So now let's send this in parallel. Now let's see if I update this. I think it is taking some time. So let's wait. So after waiting for 5 to 10 seconds, we got a responses. Okay. So if you see the email client, so from both the emails we are getting the same token. It means the probability of getting the victim token is high because uh, this token was sent to, like, if this user, then this user is getting same token. So now what you need to do, just change username to Carlos, that is a victim in this case. Now let's see if I refresh. Okay, let's see if we are getting Carlo somewhere. So no. So let us try to send again, and let us refresh again. So now just let's copy one of the requests, and we will use, because the potential that this token is also sent to Carlos is high, as I have already done here in the previous case where the two of the requests are getting same token. So just change user to Carlos, and if the token is related to Carlos, then it will link an invalid token. It means it is not related to Carlos. Now let's check for this. Again it is again invalid token. Yeah, this thing you need to do manually. Now let's try this one. If I change this to Carlos, so yeah, as you can see it worked. So token was this, and if we see, yeah, so this one worked. Now let's set a password. So we have solved this lab, so hopefully you get my point. Okay, so in this lab the main issue was the timing itself. Okay, one request was taking much more time, other one is taking less or more than it. So you have to balance the timing and try to align both the requests so that a race would happen. Race here means race condition, not that race. Okay, so thank you so much. We will now see some real life examples. Okay, so thank you so much. Hello everyone, so let me show you the first proof of concept where I was able to claim a single coupon code multiple times, and I have used repeater group tabs in this case that I have explained you in the previous labs and all. So let's see the proof of concept. So firstly you have to register as an individual or a company, then you have to, like, enter your info code to test. So we have to carefully test this functionality. So so here I have entered the coupon code, and now I am proxifying the request. Now I am proxifying, and again you have to keep one thing in mind here. Again I am saying it again and again, that if the coupon code is like precious to you and you don't have much coupon codes, then when you proxify the request, please keep the request on hold. Don't forward the request, as similar I have shown here. Okay, so the next step is very same. I have already told you in the limit over and bypass condition. So just control, you can just press control plus R, and you can just make duplicates of same request. Now you have to make a group. You can name anything to the group and just select the all similar request. Now after creating the group, you have to select the send in parallel option. So after passing it, I have observed that some of the requests worked. Like single coupon was giving me €3 for creating instances for the cloud. It was basically a cloud-based company, but I will show you and I will prove you like you can claim this coupon code multiple times. So after just uh, pressing send group in parallel, I just reviewing each and every request and response it, like how many of them work or how many of them not work. And when you enter the dashboard, yeah, so at this time you can forward the request that you have proxified. Okay, so here you can see I just claim a single €3 coupon to €24, like it is almost about 8 times. So I just claim the coupon code 8 times. So I hope you understand, and we have already done this in the lab, so it's easy to perform and easy to like predict where to check this kind of limit kind of race condition. So I just checked this with the first coupon and I was provided with some different coupons as well. So I am just directly showing the analysis of the second coupon. So using second coupon, I just send, you can see here 1, 2, 3 and almost like 8 requests, and C means claimed. So out of 8, 7 requests are claimed and one was unclaimed. So yeah, it was pretty much working well. So that's the thing. And here is one of the case, like you have to depend on company like for providing coupons code to test for their coupon code functionality. Okay, so let me summarize this for you. So let me summarize. So basically I was provided with almost 3 coupons, like, and you can see the race condition here was basically limit overrun. Okay, so one thing you have to keep in mind, like while testing, when you put your coupon code, okay, then you apply the code, then in proxy keep request on hold. Okay, please don't forward this request, otherwise the coupon will be claimed. Okay, sometimes people do mistakes, so this was a mistake I was also making sometime, so please this keep in mind. And yeah, after this send request to repeater tab. Now then after you have to like duplicate the same request, so you can just simply press Control plus R, so it will automatically duplicate the request and make multiple tabs of same request. Then after you have to make a tab group. Okay, you have to make a tab group, you can name it anything. Okay, then after selecting all the requests, send select the parallel option, basically send request in parallel. Okay, then check for race condition. Okay, if it works, then you can claim some other coupons as well, suppose XYZ 50, if it is providing 50% off, and then you can apply it multiple times. So here the case was a little bit different. So after applying coupon code, I was getting like €3, and this amount can be used in creating cloud instances in the application. But what if I multiply it with some amount like 8 times? If I claim it eight times, as I already told you, then I am having €24 in my account. So it can be a much bigger issue if I use tools like Turbo Intruder and I make more big money. Okay, so this was the proof of concept, first proof of concept basically. Okay, so thank you. So let me show you a second proof of concept. So where I was able to bypass a little business logic condition, like the company was not allowing to add user of same email, but using race condition I was able to add users of same email. As you can see here, I already added lot of them, but let me show you the proof of concept. So let's start. So firstly you have to add the email. Okay, so let me make it little faster for you. Okay, so what I have done actually, yeah, so I just proxify the add user request, as you can see here, and I just send it to repeater. Okay, if you observe here, I just forwarded the request. It means the user is added. Okay, now why I'm sending it to repeater, because firstly I want to show you like the user of same email cannot be added. Okay, so as you can see here in the response, if I try to add the user with same email, then it shows user already exists. But what if I able to add user of same email multiple times? Okay, so let me tell you in advance something, like it is not affecting the company much. It is a kind of business logic misconfiguration, but not critical or not high. And if I would say not medium in lot of cases, yeah, but it comes in category of low, because adding same user of like adding user multiple time of same email, uh, you may bypass a business logic misconfiguration, but it is not that much critical. Okay, yeah, but it's still an issue. Maybe you find some other endpoint in the company where you're able to perform some more critical issue using race condition, and this kind of issue like gives us hints like, yeah, company is affected with race condition, so you can try to perform race condition on different endpoints as well. So I just what I've just done here, I just changed the email and duplicated the tab multiple times, and now what I will do, I create a tab and merge all the requests and send them in parallel. Let's see what we got after sending requests in parallel. So as you can see, we are getting 201 created response multiple times. It means I have just created this user multiple times. So let's refresh. Yeah, as you can see here, I have created the user multiple times. So that's the issue. Again, if I would say, it is also a kind of limit overrun, because we have limit of adding one user associated with one email only one time. So we are again just bypassing a limit. I think you understood it, and let me show you similar kind of POC of another target as well. Okay, so let's see a similar kind of issue for this target. Yeah, again here is a user management system, and again there is a business logic configuration that you cannot add user with same email. Again, just capture the request and just send it to repeater and multiply the request by pressing Ctrl R and make a tab group and add all the similar requests here. Now you have to send all the requests in parallel. Let's see what will happen. Yeah, maybe it is not showing in response, but we can confirm from the dashboard as well. Yeah, as you can see here, we have just added user multiple times. Yeah, again I'm saying it depends on the company, and whether they are considering it a low or a medium, but according to me it's a low issue because no, it is not affecting their server or anything much. So it's a kind of a business logic misconfiguration just. Okay, so thank you. So let me show you another proof of concept which is kind of interesting, and here I was able to get some premium features using it, like or simply I can say I was just able to bypass some features to get privileges of premium users, basically paid users. So let me show you the background or a little research for finding this issue. So basically this was the plan provided by the target. You can see the target, and it has a bug bounty program as well, so you can hunt it on. Okay, so after analyzing lot of things and lot of research, you can say, so I was I just observed that the free user can you like create 5 spaces, but only paid users, whether it is unlimited, business or business plus or enterprise, only they have option for unlimited spaces. And even I have checked it personally. And if you try to create more than 5 spaces here, then website will show you error like this. Okay, as you can see here, the free forever plan is limited to 5 spaces, upgrade to unlimited to get unlimited spaces, and you have to pay $7 member per month, at least 7 or more you can pay as much you can use. So like what I have done here, so basically just I see the limitations here. Basically, I observed some limitations. So a very important tip, those who are looking this POC or those who have reached this video is sometimes you don't find limit in the target itself, but yeah, if there is some premium features, then definitely normal users is having some kind of limit. So that limit you can just read from the documentation itself, and like there are a lot of things. Yeah, not everyone was you can say vulnerable to race condition. Yeah, but few of them was vulnerable. So let me show you the proof of concept. As I already told you, I can create only 5 spaces. So let's see if we are able to like create more spaces. And to make the proof of concept simple, I just don't use the turbo intruder tab. I just use the repeater tab, okay, with multiple requests, okay, because you just want to prove it. You just not actually like exploiting it for your purpose. You are just want to report to the company. And turbo intruder sometime like trigger firewalls as well, as I already told you. So here we just proxify the create space request, and again do not forward this request, keep on hold and send to the repeater, and again now duplicate the request in the repeater as you are interested in this request. So basically it's the post request, it means it is creating the space. Now just select send in parallel option, and yeah, let's see what happens. Yeah, as you can see, lot of spaces are being created. So I was having limit of 5 spaces, but I was able to create lot more spaces. So it means I was able to bypass this functionality. Sorry, not functionality, a limit. So these kind of issues affect company financially as well, because you are targeting the feature base and premium or the financial kind of feature which needs some subscription. Okay. So when you proxy the request which you was which you just proxified and keeping on hold, and when you send this after some time, then you definitely get 400 by request, because this request was not participating with the previous request. which are sent in parallel. Okay, so now when you see the dashboard, so you will definitely see the result, and these kind of issues are hackers are reporting mostly nowadays because they are bypassing premium features using this. And it's a kind of privilege escalation as well, because you are getting you're able to like use features which are only used by premium users. So it's a kind of privilege escalation as well. So as you can see, I can create spaces lot more than 5, and I just use simply some 15 to 20 requests here. Using Turbo Intruder, I can just surpass these to like hundreds. So that's the proof of concept. I hope you like it. And the pretty much interesting was the angle of finding this, like from the documentation and all. So I hope you like it. So let me show you one of the similar case also. Now again in the documentation there was another feature which was related to whiteboards. Yeah, again a normal user can create just 3 whiteboards, and upgraded user can create at least from 10 to like infinity, like as many as they can. But now let's see through proof of concept. Again I was able to bypass this. So whiteboards are created through this feature. So the application sometimes contains load of functionality, so you have to focus on some pinpoint vulnerabilities. Like if I am focusing race condition, and so I should know about limits the target is putting on the features for the normal user and the premium user, and other limit as well. Again I will capture the create whiteboard request and send to repeater, multiply or duplicate the request, create tab, and merge all requests and send it in parallel. So things are pretty much same in race condition. Okay, yeah, there rare cases are involve only like multi-endpoint race conditions and time sequence based race conditions, and sometimes in single endpoint race condition. Okay, so I hope you understand. This is very similar to the previous one, so you can just see and understand. There is not much to explain here. Target was to just bypass 3 whiteboards. Can I create more than 3? Yeah, race condition can do so. So let's just refresh and see. So in above tab you can see we are able to create more than 3 whiteboards. One, two, three, four, five, six, 7. And I just let me see how much request I use here to achieve as you can see here, 1 2 3 4 5 6 7 8. Like I just use 7 8 requests and they almost all work, like 90% of them worked. So I hope you understand, and it was easy to understand, and it was limit overrun race condition. If I would name this race condition. Okay, so thank you so much. Okay, so I have a lot more proof of concepts, but the proof of concept belongs to some private programs, and the issues is not patched yet, and they are working on the issue. So sorry for that. I will not be able to show this time. Yeah, when the issue will be patched, I will update in the Udemy course section as well. Okay, so don't worry, you will get more and more examples related to this. But I think these type of examples are sufficient. So thank you so much. So till now, all the proof of concept that I have shown to you are belong to me or just belongs to me. But this one, I have found it from you can say the James Kettle. It is one of the James Kettle finding. Okay, so I have personally find this type of issues as well, but I am not showing you because of some privacy issues, and company still working on patching the issue. Yeah, but it is public and it has been patched. So I just want to explain you the methodology just. Okay, so let us start. So before starting, let me give you first the overview. So we have already seen the single endpoint race condition. So in the single endpoint, what happens if you revise in your mind? So in single endpoints, there is kind of like there is no limit. It is different from limit bypass or limit overrun. In single endpoint, we try to change uh, parameter values of the request body and try to send request in parallel, like the account takeover vulnerability of Carlos that we have seen in the lab. Just if you roll above to the lab section, so you can see that. So here the James Skettle POC, you can see he's going to the email edit option and he's trying to just edit email and confirming password, and it is very similar to the ports figure lab, very similar, but yeah, difference comes in the way of explaining and way of describing. So he just predicted it and he is now probing. So he has just made a custom code, like the code will run 10 times and the email client will be same, but the email will be changed 10 times. Okay, it means it will be sent to 10 users. But in race condition, he is observing whether in this like whether the application is working intentionally under race condition or some other user getting some different user tokens, like a case of account takeover. Like I am a user and there is a victim and I try to like get victim token here. Okay, if I try to put in race condition, so that's the thing simply, and the code is easy to understand. So you can perform this thing manually in the repeater tab as well. Just make 10 tabs and each tab just change the, like here he has added plus test 1, test 2, test 3. You can just manually do it as we have done in lab. Okay. Yeah, every manual thing has this automation. So he is doing with turbo intruder. Yeah, the best results, sorry, the basic result will be clearly seen in the Gmail. So what was the thing of observation here is this. Let me, yeah, as you can see here, the this email was intended to send to demo 6 user, but he is getting demo 6 email, basically the email token. So it means the user 6 will able to take over account of user 3. So similarly, he just observed this anomaly, anomalous behavior in this feature. It is very similar to the ports figure lab we just solved. Yeah, but he was getting token, but he was encountering some error as well. So now he has made an exploit. Again, he was just trying to align the request and try to like reach more and more race. Yeah, so here was a little email issues as well. Like if he actually tries to take over account, so he was getting some kind of error. But he used spoofed at the rate localhost email. So he was able to perform account takeover using that email, because using that email he was getting a token. So that was the thing. So the last tip I would say, like try to avoid using scanners while performing race condition. And in race condition, don't forward the proxy request. And the last thing, uh, Both tools are good. According to me, all tools are good, but yeah, try to use less request for the probing section. Like if you want to like predict and try to gain more evidence related to it, then try to use some less request. And if you use turbo intruder, then you may face difficulty of blocking by firewalls. So to like avoid this, you can use repeater properties of creating multiple tabs and sending requests in parallel. So it's a better way. Okay. And the last and important thing, yeah, you should learn customizing your code. Okay. Like here you can see he has customized his code, and according to the evidence and proofs, he just managed to make changes in the code and try to automate it. Okay. So thank you so much. Hope you like the course and hope you learned something, and you will definitely find a lot of things through race condition. Okay. If you find and if this course help you and if you find some cool stuff on the bug bounty targets, then do tag me and I will love to collaborate with you and love to hunt. Okay. So thank you so much.